Chapter 8, Part 5, we are going to look at some special quadratics. 61a, we have x squared minus 49. So to start, I'm going to look to see if I can find a GCF other than 1, and in this case I can't. So I'm going to start by saying x squared plus 0x minus 49. So I'm going to set up my rectangle, I'm going to set up my diamond, and I'm looking for two numbers that multiply to give me negative 49, but add to give me negative 49x squared, and add to give me 0x. Anytime you have 0 in the bottom of the diamond, your two sides of the diamond are going to be opposites of each other. So in this case, it's going to be 7x and negative 7x, because a 7 and a negative 7 would give you 0 and multiply to give you negative 49. So we're going to plug that in, and again, it doesn't matter which direction or what spot you put it in, and then we're going to find the dimensions. So x squared minus 49 is the same thing as x plus 7 times x minus 7. In this problem, we are using the difference of squares. The difference of squares is a factoring pattern that we can use as a shortcut. So it only works, though, if you are subtracting in between your two terms, and they're binomials. That means you have two parts. The coefficient in front of your x squared and then the constant, the number at the end, need to be perfect squares. So it has to be, 1 or 4 or 9, 16, 25, 36, any number that you can multiply with itself is going to give you a perfect square. So like 49 is 7 times 7, 36 is 6 times 6. So that is a must. They have to be those perfect squares for this to work out, and that must be a negative sign in between. So you can kind of do a shortcut for that problem. In Part C, we're going to look again to see if there's a GCF, and there is not besides one. So we're going to start with our rectangle and our diamond. And if you're getting the hang of this, you actually don't need to do the rectangle and diamond. You can kind of go right into your binomials if you want to, your parentheses. If not, keep using the rectangle and the diamond. So we need two numbers that multiply to give us 25x squared, but add to give us negative 10x. So we can think of different combinations, but it's going to be negative 5 and negative 5. So when we go to plug them in, we want to find the product, the dimensions, what's going to multiply to give us x squared minus 10x plus 25. And it turns out to be x minus 5 times x minus 5. So instead of writing it twice, we usually just say that it's the binomial squared, which is x minus 5, the quantity squared. We're going to jump down to part F, which is 4x squared minus 25. And again, it's always a good idea to start with the greatest common factor, which is just going to be a 1, so we can't really take anything out. So we could begin and say that this is 4x squared plus 0x minus 25. And we could set up the diamond in the rectangle and plug in our 4x squared, or negative 25, and multiply them to get negative 100x squared and 0x in the bottom of the diamond. So as you're going through this, remember there is that special factoring pattern, the difference of two squares. So we have the subtraction sign in between, and we have a 4 and a 25, which are perfect squares. So instead of doing the diamond in the rectangle, which you could do, it'd work out, it'd be negative 10x and positive 10x. You could, continue to work this out, find the greatest common factors of the sides, or you could look and use that special factoring pattern. So you're going to take the square root of 4, which is 2, and the square root of 25, which is 5, so we could say this is 2x plus 5 and 2x minus 5, which is the exact same thing that we got right here. So you have a couple ways of going about it. Now you don't have to use a special factoring pattern as a shortcut. If you'd rather work it out, that is totally fine. In letter H, we have x squared minus 36. And again, we're looking for the greatest common factor, which is going to be 1, so we're not going to take anything out. So you could rewrite it with the middle term being 0, or maybe, by now that you're noticing that, oh, we're subtracting, and I'm going to have a 1 and a 36, which are both perfect squares. So you could, set it up and go that route, or if you wanted to, you can continue with your diamond and your rectangle, putting x squared in the bottom left, negative 36 in the top right, multiplying the two of them to get negative 36x squared, and 0x in the bottom of the diamond. So you need two numbers that multiply to give you negative 36, but add to give you 0, which is going to be 6 and negative 6. So you can go about finding the dimensions, or, like I said, if you remember the special factoring pattern, we can just say it's x plus 6, x minus 6 by the difference of squares. In letter J, we have 4x squared plus 20x plus 25, and the GCF is going to be 1. So we are going to get started by doing a diamond and a rectangle. So I have 4x squared. I have my 25. Multiply to get 100x squared, and my 20x is in the bottom of the diamond. So we need two numbers that multiply to give us 100, but add to give us 20. Well, that's going to be 10 and 10. And then we can find our dimensions. So 10x and 4x squared have a 2x in common. And then we can kind of work backwards from there. So this is going to be 2x plus 5 times itself, which can just be written as 2x plus 5, the quantity squared. And this has a special name. This is a perfect square trinomial. Trinomial means it has 3 parts. But again, if you look, the leading coefficient there, the first one is a perfect square. So is the last one. And if we take the square root of 4, we get 2. The square root of 25, we get 5, and then the number in the middle is twice their product. So 2 times 5 is 10, 10 times 2 is 20. So like I said, there's this perfect square trinomial. It's kind of a shortcut. You don't have to, go about it that way, but if you wanted to, you could. So this would be 2x plus 5 and 2x plus 5, which, like I said, is 2x plus 5 in parentheses squared. The last example we're looking at is L, 9x squared minus 1. And this, again, is also the difference of squares. So 9 is a perfect square, and so is 1. So you could automatically set up your parentheses and say 3x plus 1 and 3x minus 1. Or, if you're not comfortable with that, we can just write it out, adding a 0x in the middle, and doing our diamond and our rectangle. So 9x squared in the bottom, negative 1 in the top right, multiply to give us negative 9x squared, add to give us 0. So this is going to be negative 3x and positive 3x. So when we go to find our dimensions, we'll have 3x and 3x. This will be minus 1, and this will be a plus 1, which will give us the same answer.